A complex number is represented by the point in a complex plane. For what it's worth, complex numbers in the complex plane can be written like that. So that's part one. The complex number has the rectangular coordinates 3, 3. Which of the following is one way to express the complex number using the polar coordinates r theta? So what I have to do is I have to turn rectangular 3, 3 into polar r theta. Once I have that, I then plug whatever x and whatever y I get into here, and that gives me my answer. So a very roundabout, pain-in-the-butt problem, but, it's AP, so it's got to be a pain. First things first, if you're going from rectangular to polar, you need two main things. Thing number one is r is going to equal the square root of x squared plus y squared. Some teachers might have r squared equals x squared plus y squared, then you square root it. It's the same exact thing. It's all Pythagoras and stuff like that. Also, I need to know that theta is the inverse tangent of y over x. So let's do some labeling. I have 3, 3. I'll put that over here. And so 3 is an x, and 3 is also a y. Happy day. So my r is going to be the square root of 3 squared plus 3 squared, which is the square root of 9 plus 9, which is the square root of 18. And this is the same thing as 9 times 2. So rip out that 9 and make it 3 root 2. So there's my r. Okay? So that's part one. We have an r. And my r is going to be 3 root 2, which allows me to eliminate two answers, but, we'll get to that. Thing number two is I need my theta. Theta is going to be the inverse tangent of y over x, which means the inverse tangent of 3 over 3, which means the inverse tangent of 1. Now, the inverse tangent of 1 is going to be pi over 4. Now, some people might be like, isn't it also something else, like something in the third quadrant? Yes, it is. But since we're given the point 3, 3, I care about my first quadrant answer only. So there you have it. I have an r, I have a theta, and that almost gets me where I need to be. Now, I can circle my answer and say, yeah, I definitely know it's A. But let's take it one step further just a little bit. Because now I have to take my r and my theta and plug it into that formula-looking thing, okay? We know that if we were to write out all the rules for polar and rectangular, that r, or rather x, is equal to r cos theta. And my y value is going to equal r sine theta. So when I plug all of this in, okay, and make it look like that, x is going to equal r 3 root 2 cos theta, which is pi over 4, plus I r, which is 3 root 2 sine theta, which is pi over 4. So a pretty gross problem, very challenging, probably one of the more challenging problems that we run into. Polar's fun, but a lot of memorization, and in this case, this is a lot of work. But we did it. We did it just fine.